Okay, let me turn this off. So what we're going to do is we're going to walk through how we solve a couple of different example problems using the mole map. Remember, from here on out, they're going to be mixed. I'm not going to explicitly tell you, oh, this is a volume at STP or this is a solution problem. You have to read it and figure out what's going on. And so we're really looking for two things. We're looking for what we're trying to solve for, and we're looking for where we start. Keep in mind that what you're trying to solve for is one of these four variables or moles, and vice versa. Where you start is either one of these four variables or moles. That's it. Can't be anything else. Like, we don't start one of these problems with pressure, right? We don't start one of these problems with concentration. We start with either liters or grams, and we solve for moles or liters or grams, or vice versa, okay? So let's check out that first problem on there. What is the volume? So the volume is by the question word. So I know I'm looking for volume, right? I know I'm looking for liters of a container that contains 0.5 moles. So that's pretty significant. Remember, I said that our starting point is either going to be moles or grams or liters. And it tells us that these moles are at negative 30 degrees Celsius and 1.5 atmospheres. Okay? So I am looking for liters and I have moles. So let's look at our map really quick. I have moles. So I'm starting here in the center of my map. And I'm looking for liters, right? So I'm not looking for grams. I can ignore that. It doesn't say anything about grams. Now, the liters, it tells me, are at negative 30 degrees Celsius and 1.5 atmospheres. So would that be liters of gas at STP? No, because it doesn't straight up say STP, right? And it's certainly not liters of solution because A, it doesn't say solution, and B, there's no mention of the concentration. What it does give me is temperature and pressure, right? So I'm starting at the mole and I'm solving for liters, not at STP. Does everybody see how I came to that conclusion? All right. And to go from moles to liters of gas, not at STP, we're going to take the ideal gas law and manipulate it like this to solve for that volume. Okay. So for this problem, we're going to do V is equal to nRT over P. So N is the number of moles. How many moles are there? 0.5. R is, of course, our constant, 0.08206. T is the temperature. What's the temperature of this solution? Or not solution, of this substance, sorry. Almost. Good guess, right? We take negative 30 degrees Celsius and we add 273. Yeah, so it would be 243, right? Because negative 30 plus 270 is 243. And then what's the pressure? 1.5. So then we're just going to plug that into our calculator. So 0.5 times 0.08206 times 243 and divide by 1.5, and we get 6.65. And of course, what's the unit on that answer? What do we just solve for? Volume, right? So this is liters. Now, here's a habit that I would love for you to get into, and mainly it's for me. If you could like circle your answer or put a box around it or highlight it or draw a heart around it or something so it stands out, that would be amazing, right? But that's mainly more for me than you. That way I don't have to hunt and peck and guess what you want your answer to be. Okay? Easy, right? All right, let's look at number 2. How many moles? So the how many is by the mole. So I'm looking for moles, right? So for this problem, we're going to the center of my map. How many moles of sodium chloride, usually the identity is important to us, have a mass of 300 grams, right? So I'm going to moles. Where am I starting? What do I know about my solution? I have 300 grams. So I'm starting here with 300 grams and I'm going to moles. What do I need to know about the sodium chloride to do that? Molar mass, right? I have to figure out what's the mass of 1 mole. So I look on the periodic table and I see that sodium is 23 and chlorine is 35.45. So that gets me 58.45 grams. And again, that's equal to 1 mole. So that's my conversion fact. Is that where I start? No. I start with what it told me in the problem. I start with the 300 grams. And that's my conversion fact that I use to cancel my grams and turn it to moles. Now, probably without looking at the map, you would know how to set that problem up. But if you don't, you can look at the map and you can see that I'm going to write the equation in this format so that it turns into moles and cancels grams. So again, some of you might need to use the map all the time. Some of you might never need it. Some of you might have to use it every once in a while. But now you have it, right? So I write it in that format so that the grams cancel and I'm left with moles. And I get 5.13 moles. And again, we're going to circle the answer. All right, let's look at number 3. Number 3 again says how many moles of chlorine gas. Big clue, right? It's a gas. On our map, there's only 2 gas options, so I know it's one of these. It says gas at STP. So where am I going to be starting? Here, right? How many moles of chlorine gas have a volume of 75 liters? So we're going to start with 75 liters. And as we know from the map, in order to convert liters of gas to moles, we're going to have to use the conversion fact that 1 mole is equal to 22.4 liters. When we go from liters to moles, we're going to write the conversion fact as this fraction. Again, I believe many of you can probably do that without having to even look at the map, right? So we put the 75 liters, we put the conversion fact as 1 mole on the top and the 22.4 liters on the bottom so that the units cancel, / that's what the map told us to do. And then we do 75 times 1 divided by 22.4. Sorry. We get 3.35 moles. And again, we'll circle our answer. Now, real quick question. Would this problem have changed if this said hydrogen gas or water vapor or carbon dioxide? No, because this fact is true. 1 mole of any gas is 22.4 liters, right? Now, if this problem said something about mass, then would it change if it was fluorine gas or water? Yes. So for grams, that's the only one where the identity changes. So just kind of keep that in mind. All right, last one real quick. This one's a little bit more tricky, and this one is why the map, I think, is so helpful. It says how many grams, right? So that's where I'm going. I'm going here, right? This is where I'm headed on my map. That's my destination. How many grams of glucose are needed to make 350 milliliters of a 1.75 molar solution? So some big clues. First of all, the word solution, right? Where do we only have solution at on the map? Here. So we must be starting here because that's the only thing that has to do with solution. Also, it tells us 1.75 capital M. That means molarity, right? So it gave us the molarity and it straight up said solution. So we know we're here and we're going to grams. Can we go straight from liters to grams? Is there a road that way? No, right? We're going to have to go to the mole first. And then once we know our moles, then we can go out to grams. Okay? So to start at liters, we have to know liters, right? Do we know liters? Kind of. We know 350 milliliters. What do we do to convert that to liters? Good. So we're going to divide by 1,000, so we get 0.35 liters. And we can see on the map to find the moles, we're going to take the molarity times the volume. So molarity times the volume. That's going to get us 1.75 for the molarity, and the volume is 0.35. So I do 1.75 times 0.35, and we get 0.61 moles. Now, are we done?
No.
No, that only got us to the center of the map, but it asked for grams, so we need to go one more step. We need to go from the mole out to the gram. What do I have to know about my substance in order to go from the mole to the gram? The molar mass, right? And when I do that, you can see here, according to the map, that I'm going to multiply by the molar mass over 1 mole. So we got to figure out what the molar mass of glucose is, right? So it's going to be 6 carbons, 12 hydrogens, 6 oxygens. I'm just going to tell you that it's equal to 180 grams. Actually, it's 180 and change, but I don't feel like dealing with the decimals right now, so we're going to be aggressive rounders. So we're going to do 0.61 moles. And we have to take this conversion fact and write it here so that units can cancel. You can either do that in your head because you're so good at that, or you can look at the map. The map says to put the 1 mole on the bottom and the molar mass on top. And the reason the map says to do that is because that's how you'd cancel those numbers. So we're going to do 0.61 times 180 divided by 1. And we're going to get 109.8 grams. You guys, I don't think you're going to have any more fun today than doing this. I just don't think you are. It's a lot of fun.